Okay, great. So this video is going to overview solubility and also solubility rules. So the first order of business is differentiating between solubility and insolubility and defining a solute, a solvent, and a solution. So solubility is when a solute is going to become cohesive with a solvent. So an analogy and a comparison could be salt being a solute while water could be a solvent. And that solution, that combination is going to yield salt water, right? Okay. So now that we've talked about what a solute, a solvent, and a solution is, let's talk about insolubility. So what happens if a solute isn't cohesive with a solvent? That's going to be insolubility. And a classic uh, comparison and analogy is going to be our oil and water picture right here. So as you can see, there's olive oil being poured into water, and that's going to create insolubility. But why is that? Well, it has to do with something called polarity. So polarity has to do with the symmetry and the distribution of a molecule's charge, right? So let's look at water, for example. Water is a polar molecule. But why is that? Well, it's polar because it has an asymmetrical distribution of charge. So this allows it to behave in different ways than nonpolar substances, right? Cool. So now that we have that established, let's talk about what a nonpolar molecule does. So a nonpolar molecule, like oil, is going to have a symmetrical distribution of charge. That's going to make it behave in ways different from polar molecules like water. Okay? That means they can't mesh. That means they can't be cohesive in water. So water and oil aren't going to mesh. They're not going to be cohesive. But what about oil and oil? So that's going to be okay. And that we come to our like dissolves alike. So if we have oil in a cup and then we pour oil into that, that's going to be cohesive with each other. They're going to mesh because they're both nonpolar. So the main idea from this is that polar is meshes with polar, then nonpolar meshes with nonpolar. And anything outside of that is most likely going to be insolubility produced. Oops. But not always, though. There's some exceptions. So here we have our solubility table. And this is going to be used to see which ions are going to dissolve in water and which aren't. So as you can probably see, things like nitrates, acetates, chloride, bromide, iodide, they're going to be soluble for the most part, except for this group, um, silver, lead, mercury, not going to work. Then we make our way down. We're seeing sulfates with some exceptions, carbonates, phosphates with exceptions, hydroxides, sulfides. So sulfides and hydroxides are actually going to be insoluble with most things, and except with Na and potassium, right? And then hydroxide with Ba and Ca, right? So barium and calcium, they're going to be slightly soluble, but not completely soluble. So then we make our way down to sulfides, and they're going to be mainly insoluble as well, except with Na, K, NH4, and those of the alkaline earths. So we got magnesium, calcium. So yeah. Finally, we go down to NaK and then NH4. So these are all going to be soluble. So yeah, this is the table, and you can refer to this and or memorize it. So yeah, hope you enjoyed the video and hope it helped.